We're going to wrap up something that we've been talking about a little bit over the past couple weeks, which is how you can integrate virtual threads with various other kinds of things in modern Java. So we saw how virtual threads, being a new feature, can be integrated in with things like Spring by using those beans so that you make every incoming client request handled with a virtual thread as opposed to a platform thread, which is the default or a pool of platform threads. And now we're going to talk about how you can extend the Java CompletableFutures framework in order to be able to have it use virtual threads internally. So Java CompletableFutures, as we've seen a couple times, we're going to look at an example here in more detail in a moment. This is something that was enhanced in Java 9 and henceforth to be able to support custom implementations of where the threads come from that carry out the requests asynchronously. And the way this was done was by adding three new hook methods to the CompletableFuture framework that started out in Java 8. The first method is called default executor, which is a factory method that returns the default executor used for methods that don't specify an executor. So you can specify an executor, but if you don't specify an executor, by default it was using the common fork join pool, and now you can tell the framework which executor to use, and that will figure prominently in getting support for virtual threads. There's another factory method called new incomplete future, which returns a new completable future that will then be used throughout the rest of the processing to do the computations on it. And this will allow us to be able to define our own subclass of completable future and then have this factory method return an instance of said subclass when needed. And then the third and final method is called complete async, which for a long time befuddled me as to what the purpose of this method was. But once I understood that you could customize the CompletableFutures framework, it made perfect sense. What it does is it takes a completable future that's passed to it, and then it will complete that completable future asynchronously using the value given by the supplier. So I should pass to it's the wrong word. It's basically going to be used as a completion stage method and will be given the supplier to complete the computations. We'll see how that gets used as well. So let's take a look and see how this works. So what we're going to do here is implement a little helper class, and I'll show you this in more detail, but this is just a high-level view. This is the CompletableFuture EX class, which extends CompletableFuture, so it extends it. That's what EX stands for. And it's got a couple of methods. First of all, it implements CompletableFuture, so it's going to override these hook methods that are defined in the framework. It defines a private static field that's going to, by default, execute or create a virtual thread per task. So you can see we have this executor that says executors.new virtual thread per task executor. So it's going to make us an executor that will create a virtual thread each time it's used. Then we're going to override the default executor method to return that executor that makes a new virtual thread every time. Then we're going to define a new incomplete future factory method that's going to return an instance of new CompletableFuture EX, which doesn't have any implementation associated with it. That's going to come with the next method. And then the final method here is called supply async. And what supply async is going to do is it's going to take a supplier and it's going to make a new completable future, one of these guys, and then it's going to go ahead and complete that completable future asynchronously using the supplier that's passed into it. And so that's basically how this particular framework is going to work. So given that as background, we're now going to look at a cool example that will demonstrate how to use this feature, and then we'll see how it performs relative to alternative approaches.